This lesson is going to look at solving systems that have special types of solutions. So let's first take a look at this system. This system, both of the equations are solved for y. So we can do this one of two ways. We can do substitution and substitute one of the equations for y, or since they are already lined up like terms, we can use linear combination or elimination. So I think that is the method that I'm going to go for this particular system. So they already are lined up, but we have to make one coefficient opposites. So the coefficients of y are both 1, and the coefficients of x are both -2. So it does not matter which one we make opposites. So let's look at x. So if I want to make x the opposite, they're both -2. In order to make one the opposite of -2, which would be +2, I'd have to multiply one of the equations by -1. So I'm going to multiply the top equation by -1. So that means -1 times y is -y equals -1 times -2x is 2x, and then -1 times 5 is -5. And then I'm leaving the bottom equation exactly the way it is. So now I have my x values opposites, so now I can add them together. So if I add them together, -y plus y, they cancel each other out because they're opposites, right? And if they're opposites, they leave you with a value of 0. So I have 0 on that side equals 2x plus -2x. They are also opposites, so that's 0. And then -5 plus 1 is -4. So I really end up with a statement 0 equals 0 minus 4, which is -4. Remember when we solved equations that were just regular equations before, if we got down to a statement like this where all the variables were eliminated and it was a false statement, that meant then that there was no solution. So what does no solution actually mean for a system of equations? This is the exact work that we just did. However, in this work, I made the bottom equation the one that was opposite. But still, we got a false statement at the bottom, which means no solution. Remember that a solution to a system is the point where the two lines or two equations intersect each other. So if there's no solution, that means that the lines never intersect, right? Because then there's no point where they cross. So if there's no solution, that means then that these two lines are parallel. This would be an example of those two lines graphed, and as one can see, they do not intersect, they are parallel. Let's take a look at another situation that we could have with our systems. So again, our systems are already lined up, are like terms. So then we can look at going ahead and having one variable be opposites. Again, let's focus on the x, only because it comes first. So you could have done the y's as well and still ended up with the same final answer. So if we're looking at the x values, I have -2 and -4. In order to make -2 and -4 is the opposite, I'd have to multiply that top equation by -2, right? Because -2 times -2 gives me the +4 for the opposite. So I'm going to multiply this whole top equation by -2. So -2 times -2x gives me 4x. -2 times y is -2y, and then equals -2 times 3 gives me -6. So then I have my second equation, which I'm leaving the same, so -4x plus 2y equals +6. I now have my x's opposites, so I can add them together. I have no idea what just happened there. There we go. Okay. So I can add them together. So I have 4x and -4x, they're opposites, so that's 0. -2y and 2y, they're also opposites, so that's 0. And then -6 and 6, those are opposites as well, so that's 0 as well. So the statement I get is 0 equals 0. This time that's a true statement, so remember when we did that with the regular equations, that meant that there was infinite solutions. So again, remember with a solution being the point where the two equations in a system intersect, infinitely many solutions then means that the lines intersect infinitely many times. So basically what that means is that they are the same line. As this proves, when you graph the equation, both equations produce only one line on the actual grid. So when you solve a system of equations, three things can happen. Your lines can cross each other, which means that there is one solution, and that solution is where the points intersect. The lines could be parallel, which tells you then that there are no solutions, or when you solve that equation you got a false statement. Or the lines could be exactly the same, which means that there are infinitely many solutions, or you got a true statement when solving it using an algebraic method.